give a huge round of applause for Sayak Paul.
Hey everyone. Yeah, I would like some focus here. I know DJ is probably the best speaker amongst us, but I would really appreciate it if you could support me because this is my first time talking at DevFest Indore. You know, I have fond memories of Indore. As a kid, I used to come to Indore quite often to visit my uncle. Now my uncle has moved back to Kolkata. Now this is me coming to Indore after 20 long years. So yeah, fond memories. And today in this talk, I would like to talk to you about sharing my experiences as to how we can collectively improve as machine learning practitioners. Now, to set the context right, I really need to know how many of you are into ML in the first place. Yeah, that seemed like a low number, but don't let the title of my talk scare you off. Because even if you are just starting or if you are a seasoned practitioner into the field, I hope there will be something for each of you to take away from. Because I have designed my talk that way. There's something for everyone. If you are interested in the field, I hope my talk proves to be useful. Uh, okay. Here's a bit about myself. I'm a developer advocate engineer at Hugging Face. How many of you know about Hugging Face? Anyone? Okay, that's a fair number. Okay, good. In the past, I have worked at companies like PyMed Search, TCS Research, and I also have a flair for contributing to open source libraries. In particular, I have contributed to Keras CV, Hugging Face Transformers, and I'm still actively doing that. And off the work, I like being a Netflix nerd, and currently I'm binging Khaki. I think it's a really good one. I think I'm in the 4th episode. So yeah, without any further ado, let's actually get started. How many of you agree with this statement? ML is fascinating. बाकी सारों को क्या हो गया? नहीं लगता? ML is fascinating. If that's the case, I'll try to convince you that ML is indeed fascinating. Let me take one example. So here on the screen, the blue text that you are seeing, it was actually predicted by an ML system. So what I did was, I gave it a context, and I then asked the ML system a question, and it kind of correctly predicted the answer. So in order to get to the text in the blue, it had to reason about the context, it had to sort of understand the question, and then it had to come up with a plausible answer. So this is one example as to why I think ML is fascinating. And then I'm going to have to ask you for a short exercise. So read this caption on the right-hand side. A 3D render of an astronaut walking in a green desert. Now take 5-10 seconds and imagine an image closely matching this caption. First of all, green desert does not exist. So you will have to be a bit more creative than usual. But yeah, take your time. I'll give you 10 seconds. 7, 6, 5, 4, 3, 2, 1. And believe it or not, it's an image generated by an ML system. Real enough? The image looks real enough? Looks fun enough? Looks creative enough? Yeah? Take a look at the level of reality. Take a look at the level of compositionality it has, right? It has got a certain feel of mastery to it. So believe it or not, this image was actually generated by an ML system, and I only prompted it with this caption, a 3D render of an astronaut walking in a green desert. First of all, again, green desert does not exist, but it still sort of thought it, came up with a plausible looking image. So yeah, I hope with these two examples, I was able to convince you that ML is indeed fascinating. Now here are a couple of more bold statements for you. ML is an enabling technology. The reason why I say that is, imagine Google Photos without all the intelligent factor incorporated inside of it. Right? Imagine Google search without the intelligent search results. imagine Facebook without intelligent suggestions, if you know what I mean. So I think ML is an enabling technology. It has enabled many amazing, applications across multiple different verticals. And no wonder why it's taking a huge market share as far as the talent market is concerned. I'm sorry, Angular folks. ML is indeed going to be one of the most important technologies in the coming days. And almost everyone wants to make a career of it. It's not like ML is going to be a niche technology. I envision ML to be present in the toolbox of every other developer because of its craze, because of the impact machine learning can bring in a particular application. But it's not easy, right? If you ever wanted to make a career out of machine learning, even remotely, you would know that it's not easy. And I'm gonna explain why it's not easy. All right. So ML is an interdisciplinary gig, and by what I mean by that, because ML is not just about programming. Even if you are a Dennis Ritchie of programming, it might be the case that you are unable to debug a simple machine learning model. But that's not gonna work. As a machine learning practitioner, you need to have a combined understanding of programming and also the science part of it. And by science, I mean things like probability, statistics, all the usual plus two stuff, plus two science stuff. So you see, it's not just about programming. You need to also have a fair grasp of science. And also, you need to be able to communicate your results. Because after you're done coding a particular machine learning project, you should be able to communicate what you did in the project in the first place. And things in ML are usually more non-trivial than the other software engineering projects. And I'm going to explain why that is in a moment. So you see, ML is an interconnected discipline. It's not just about programming. It's not about a particular one thing. Like, you have understood JavaScript, okay, now what? So you also need to incorporate the science element inside of it. And also, ML evaluation happens at a pretty rapid pace. Right? Let's say you have a set, design pattern when it comes to software engineering. And in the ML world, that design pattern, that may get out of date very quickly. I'm going to give you another example. So batch normalization, this thing called batch normalization, think of it as a design pattern like you do in software engineering. So in 2022, this specific component from machine learning called batch normalization, it used to be really popular up until 2020. Like in our textbooks during our undergrad machine learning courses, we all were taught about batch normalization. Now in 2022, it's almost no longer used. So the thing that we were taught in our textbooks in, let's say, 2017 or even 2020, it's no longer even used today. So that's why I mentioned. Sorry, why it's going forward? Okay, yeah, that's why I mentioned ML evaluation really happens at a rapid pace. So here's where I gave you a brief idea. The thing that was popular in 2020, it's not even used in 2022. So that's why, often when you are dabbling in the field of machine learning, you often, may not get a sense of progress or accomplishment in the first place. And without that, little feeling of accomplishment or pride or progress, whatever you say, things can get difficult. And if you're thinking like it's a pep talk, I'm going to convince you it's not a pep talk. We'll keep it technical in the context of machine learning, but let's first acknowledge it. If you are not feeling any progress, if you're feeling like your progress has been stuck, if you're not feeling any sense of accomplishment in any field you are working on, things can get difficult. It can depress you easily. It has happened with me, so felt like it can generalize. So yeah, hence this session exists to sort of share my experiences, my learnings over the years that I have found to be useful to improve as a machine learning practitioner. I'm going to share my experience from both the stages, when I was a student during my undergrads and when I started my ML journey professionally. So I hope the learnings I'm about to share, they're useful for you, no matter where you are in your ML journey. All right. So here's where we start the meat of the talk, where I share how we can improve as ML practitioners through my lens. So this is a highly opinionated talk. So as a disclaimer, I'll have to request you to take all of this with a pinch of salt. So first things first, you might want to ask yourself, why are you in it for? What excites you more? Is it the machine learning modeling part? Is it the data part? Or do you want to just focus on the model deployment part? Like, what part of machine learning, because machine learning is pretty vast, it's a broad field. What part of machine learning excites you more? If you want to, try out all the things that are, possible in the world of machine learning, it's all good. But you need to settle down with that point of excitement that's really interesting for you. Because if things are not interesting for you, you won't be able to pursue them uncompromisingly. And without that excitement, things will feel boring too quickly. So, and also, I like to emphasize this bit, the last bit. Being passionate about something involves all of it, the good, the bad, the ugly. It's not like machine learning is all about flowers and butterflies. It's not like that. You need to prepare yourself for the worst of the worst cases where you need to really, dive deep into a particular model architecture to be able to debug it in the first place. So be prepared for those days. Now, as the popular saying goes, what can't be measured can't be improved. So maybe you would want to ask yourself, the last project that you did, what impact it had? Did it help, help a business drive its business revenue? Did it, did it lead to more user engagements and so on? Here are a couple of example questions that I would have asked to myself. So just some examples. And you don't need to click pictures. I'm going to share my slides with you anyway at the end of my talk. So yeah. So these are some questions that I usually start off with. So long story cut short, I like to see improvement as a function of impact. The kind of impact, the improvements that you are making along the way, the kind of impacts that you are making. So that's why I like to see improvement as a function of impact. Now, if still you were thinking, I'm not really here for a pep talk, it's not one. It's not a pep talk. Now we are studying why. Now let's take that scenario where we all are ML professionals, meaning I have an ML specific job, I'm already employed. Now, why would I want to improve? I have already got the job, right? What's possibly there to improve? So you probably want to just raise a bar, and probably your next job includes a broader set of skills. Probably that's why you want to improve. These are some questions you might again want to ask. These questions can vary from person to person, but these are questions that I often ask myself. Before taking on a project, before working on an open source project, and so on. Now what are the things that we as ML machine learning practitioners could focus on? Like often we focus on model training, often we focus on writing a very niche model architecture. Okay, all done, model training done, all in good. Now what about the next step? What about deploying that model in the first place to serve the next 1,000 users? Let's not go to billions. Let's say what about serving that model to 1,000 users and then slowly scaling it up? What about scaling that model from, often we code models inside a notebook. How about taking that model out of your notebook and deploy it in a scalable manner? Right. And what about reproducibility? Can you ensure your model runs the way it's expected to run? Meaning, given, let's say, an image of a 6, it's not predicting 4. Every time you're running it, it's giving you, different predictions. It's not supposed to be like that. You need to ensure your models are as reproducible as possible. And what about, implementing monitoring systems during production? Of course, these are usual software engineering things, but when it comes to machine learning, things can be different. Because what you are exactly monitoring when you have deployed a machine learning model to production? What exactly you are figuring out, what exactly you are trying to monitor? These things, they may have different answer from applications to applications, right? And in machine learning, things are way more non-trivial. than regular software engineering projects. Now, here I would like to, discuss the same things, but from the lens of students. Now, let's start with the why. The why part is pretty clear. I want to land a job in ML. It's pretty clear. Let's cut the crap. I really want a job. I really want to land a job in machine learning. That's why I'm trying to sort of improve my skills, hone my skills, learn new jobs and stuff. Now what? The first part is really important. I can't emphasize on it, more. Open source, and open source, and open source. Because I'm going to explain why open source is really important, but here's the sneak peek. With open source, you get to interact with a lot of, interesting folks, and you also get to make an impact directly. Imagine, contributing to your favorite open source library. That way, you are directly contributing to its large user base. Because if you know the change that you introduced in one of your pull requests, if you know that that change is getting used by thousands and thousands of developers across the globe, that's a very wholesome feeling. And then document the things that you are currently working on, document the things that you are finding to be challenging in the first place, and how you are approaching the solutions to those challenges. So document all of that stuff. And in machine learning, you might already be knowing this. Reading papers comes as a part and parcel of the job. So if you're reading a new paper, maybe try to implement some parts of the paper. That way you will know the nitty-gritty of the paper even better. So just don't stick to the reading part. Also try to take a stab at implementing some parts of the paper. And also learn about stuff that integrate really well with ML. And these includes, in my opinion, Docker, Kubernetes, Elasticsearch. All of these things integrate pretty well with machine learning. So when you will be asked to scale any machine learning system, Docker, Kubernetes, these things will come in handy. So if you are just starting your journey, if you know that you are good with fundamentals, it's now time for you to start learning about these things, because these things will come in handy if you land up a machine learning job anyway. Now, all right. So there are also some common grounds in between the practitioners and also the students, and these pointers basically apply to the students as well as the machine learning professionals. Now, again, as I was mentioning during the beginning of my talk, ML is an interdisciplinary gig. Where do I exactly focus on? Do I focus only on ML ops? Do I implement some parts of the paper? Do I pick on something of my own? Do I try to mix and match in between different ideas? Or what happens if I do not know about some stuff needed to start a particular project, right? And here's my take. I say all of it, bit of all. Maybe, work on some MLOps related bit. Maybe, spend reading a paper and implement some parts of the paper in the first place. Spend some time with all of these points that I have mentioned, because in my opinion, they are all pretty useful skill, especially if you are a machine learning practitioner. Now, picking something interesting to work on, this can be, again, very challenging. What possibly could I start working on that's interesting enough in the eyes of recruiters? Because when a recruiter will take a look at your resume, they will need to find objective evidence that you can apply machine learning to challenging real-world problems. So now, how do I build that portfolio? How do I have a portfolio of interesting projects? For that, I really need to pick up something interesting in the first place, right? So here's what I like to do. I try to take a look at what others have done, and I try to draw inspiration from them, because the more you do this, the more developed your vocabulary will be. It's more like the more enriched your vocabulary is, you will probably in a better position to write better essays and so on. So if you have got a vocabulary of good and well-polished projects in machine learning, you will probably have a better idea of what possibly you could work on next, and draw some ideas from the existing projects that you have already studied. And here are two examples that I wanted to give you. First one is PDF to audio, and it's available for free on YouTube. So in this project, using existing APIs, Dell, the creator of this project, her name is Dell. So using existing machine learning APIs from Google Cloud, she basically turned, PDF machine learning papers into audio books. So that's an interesting thing where she, incorporated machine learning APIs to generate, text from speech. So again, speech to text is text to speech is just a fancy keyword. She actually turned a great application from that fancy keyword. Now here's another one where she made a video archive where she is basically allowing her users to enter a search query, and then from an internal database, she will fetch all the videos that is matching with that particular search query. So this way, again, using existing APIs, she was able to build a video archive that takes just natural language search queries and retrieves all the videos that are matching the search query as closely as possible. So here are some takeaways. Being able to minimally reproduce something, it's still a useful skill. Imagine being able to reproduce Google search minimally, not entirely, but minimally, because that way you are immediately exposed to different technologies that are behind Google search, at least some part of it, 1% of it, but you still learn something new, and you also learn the engineering process along the way. Now, if you are looking for something new, if you are looking for fresh problem statements and you are unable to ideate on fresh problem statements, Kaggle and Papers with Code, these two platforms could be really helpful for you. And if you're thinking about regional problems, let's say agricultural problems or environmental problems or Indic languages, because language technologies around Latin script languages like English, Spanish, they are pretty common, but what about Indic languages? Like what about app localization and stuff like that? There we have real opportunities, because language technologies around Indic languages, they are pretty rare. I mean, good. When it comes to good language technologies around Indic languages, they are pretty rare. So, think about the opportunities that you could get by working on regional challenges. Like, you might be able to come up with a good data set that will allow other researchers to also, participate in the problem that you are trying to solve. Then there will be lots of collaborations. And of course, at the end of the day, you will be able to contribute to a good cause, a national cause maybe. And especially for non-ML practitioners who want to venture into the world of machine learning, I have written a blog post which might be again helpful for you. I have heard from many of my non-ML friends that this blog post was helpful for them. That's why I thought of popping it off. And some notes about open source, because I keep talking about open source, but I wanted to share some extended notes about it. If you want to build your own open source library to solve specific machine learning tasks, please go ahead and do it. You have an amazing example right in front of you, segmentation models PyTorch. Okay, yeah. So it's an incredibly impactful library. It started off as an individual open source project, and then the entire machine learning community sort of joined the efforts. And again, solid code base with complete test cases and solid documentation. So if you want to work on your own standalone machine learning library, please do consider these points. Like what's the kind of impact the library will have? What about the code base? What about the code coverage? And what about the documentation? Because as they say, without documentation, there is no MVP. There is no minimal viable product. And if you want to contribute to a great open source library that's already existing, that's again a valid cause, because that way you get to interact with awesome folks that are already accomplished in the field, and you also get to improve and validate the skills you have. Because that way you get to apply the skills you have learned over the years and use that to contribute to something greater. And here's some of my bits around communication, because as I was mentioning, it's a good practice to document about what you are learning, what kind of challenges you are facing while doing a particular project, and how you are approaching the solutions. So yeah, you need to sort of communicate what you have worked on in a clear and concise manner. Because if you have documented that thing, that will go a long way. And you don't have to take it from me. take it from the good folks, like Jeremy Howard, David Robinson, and so on. These are already pretty accomplished folks in the field, so take it from them. And here are some takeaways for you. So it's like keeping an open mind for wanting to improve, and also it's also about enjoying the challenges along the way and keep at it. Like it's not like I have contributed to an open source library and for the next 1 year I do not do anything. It's not like that. Consistency is the key. No matter how small your contributions are, they will slowly start adding up. And if you want to take a look at my slides later for your own references, you can scan this QR. If you want to take a photograph, I'll allow 5-6 seconds. And yeah, that's about it. If you have any questions, feel free to ask. Looks like I have some questions. Any questions? You can ask me anything pertaining to machine learning, open source, anything. I'll be around, so if you think of any questions, just feel free to grab me and we can discuss. No questions? All right. Thank you, folks. Thank you. Pleasure talking. We have a question? We have a question? We have a question? There? Where?
Hello, hello. Hi, Sayak. My name is Shyam. आ गया तुम? Okay, so my name is, okay, my question is that why are we not using batch norm these days? Because batch norm seems to be very popular back in the time.
Yeah, sure. Good question. So batch norm is one of the most formidable components where? Convolutional neural networks. Do we use convolutional neural networks in 2022?
We use transformers.
So you have your answer.
Okay, so.
Anyone else? Go ahead.
Sir, if I want to go into machine learning, should I start with projects right now or should I just learn about Kubernetes or Docker first?
Fundamentals first.
First fundamentals. Okay.
Fundamentals.
Thank you.
Without fundamentals, you won't be able to make any sense out of anything. So, that lady has a question.
Hello. So this is Zafar.
Sorry.
We know how to deal with the ML in a structural or non-structural data. So how can we deal and how can we say that that is the best algorithm to deal with unstructured and structural data? So who is the best algorithm? There are lot of algorithm. So who is the best algorithm to deal with the data?
Before I answer your question, can we have some silence? I mean, yeah. Please be helpful to yourselves in the first place. So see, in machine learning, there's a popular saying called, there's no free lunch theorem. There's no one particular best algorithm for any given data. So what I'll recommend you doing is, you take any unstructured database like images or natural form of text and so on. You pick up 5 different models that might be suitable for your data, and then you start experimenting, and then you start recording the matrix you wanted to optimize in the first place, and then pick the model that satisfies your matrix and also the business matrix. Be in touch with all the business stakeholders to sort of decide on that metric you would want to optimize, and pick that model from that set of 5 models that is giving you the best results. So I'll follow this for also structured data too. And long story cut short, there's no one single model that I can say with confidence will be the best one for you. I'll probably give you 5 models to try out, and then I'll let you pick something that optimizes your performance. So yeah. Sorry?
Structural data is a paid now, so how can we optimize?
Structured data is paid, sorry?
Somewhere the structural data type is paid from, you can buy.
I see. Yeah, there are lots of services where if you want to buy data sets, like if you have a business domain for which you want to buy a particular data set, you can buy. There are lots of vendors, but I mean, I probably do not get your answer. Are you looking for portals that provide data sets for fees?
Structural data.
Structured data? What
Yeah.
kind of structured data?
Any type of, we wanted to know the ski, as a beginner, we wanted to learn kind of,
If you are looking for data to just practice, then probably look at Kaggle. Kaggle will give you n number of structured data. Like there are lots of free structured data available at your disposal.
yes,
So the platform's name is Kaggle. Kaggle. Kaggle.
I know.
Yep. Start right there. And if you are looking for something more specific, then I'll probably have to get more context to be able to suggest better. Like what kind of domain you are looking the data for. Go ahead.
Jain sir, my name is Harsh,
Jain.
and my question is how can I grab a job in ML field? Because whenever there is a requirement of a company, even experienced people apply for that job.
Yeah.
And freshers won't get any opportunity. So as a fresher, what should I do to grab?
I'll go back to my first point. Open source, comma open source, and open source. I'm gonna explain why. Because if you are already contributing to a particular open source library, let's say TensorFlow. TensorFlow is a very popular open source library that's primarily maintained at Google. If you have already contributed something non-trivial to TensorFlow, that tells me what? You have read the TensorFlow code base up to some extent. You have an understanding of the underlying concepts that were required to make the PRs in the first place, and your code has been already reviewed by Googlers. So what other answers am I looking for?
But as a beginner, what can I do? Means that
So
understanding TensorFlow is difficult.
if you are looking to build those chops in the first place, I'll suggest start with the fundamentals. Like start with Python programming. If you do not know Python programming, be comfortable programming in Python, because Python is the most popular language when it comes to machine learning. Sorry, Angular folks. So start right there. Start learning about Python if you haven't already. Then also, if may I ask you, did you have science in your +2?
No, I have commerce.
So no, it's not a problem. It's not a problem. There are plenty of great resources. Like you could take the ML specialization. It's available on Coursera for free. So it will teach you the basic stuff that's required to get started, to be comfortable with any machine learning project. So start the fundamentals, but at the same time also start learning about Python, because it's important to apply what you are learning. And without knowing a language, you won't be able to do that. So Python and that ML specialization course, if you can strike that right balance, things will be easier for you. And if you still have questions, feel free to email me. I'm always available.
Thank you very much, sir.
Anyone else? All right, I'll take this one. I have 7 minutes of time, so I'll take lots of questions.
Hello.
Go ahead.
I was asking what can be a pathway to implement ML models for quantum computing? And is it even beneficial at this point?
Right. So my domain is not quantum computing. I mostly work in the domain of computer vision, natural language processing, and speech. So quantum computing I have never worked with, so I'm not gonna pretend to give you a good suggestion. So I'm sorry.
And about cryptography?
Again, cybersecurity is not my domain. I have never worked with something that marries cybersecurity and machine learning, so I'm sorry.
Hello.
Hello.
So, do you recommend some resources for beginners to start in machine learning?
Sure. If you are more comfortable with video-based courses, then ML specialization on Coursera, it's taught by Andrew Young, one of the OGs of the field. It's available for you for free. You can audit the course for free. The specialization is called ML specialization. It's from Stanford. It's taught by Andrew Young. It's there on Coursera. And if you're more like me, if you are more like a reader, then Grokking Machine Learning. It's from Manning Publishers. Again, you can read the book online for free.
Okay,
Grokking Machine Learning.
So these are all beginner friendly?
All beginners.
Okay.
It does not assume any prerequisites.
Okay, thank you.
Hello. Sir,
Take that one.
hello, sir. This is me, Peswani.
Hi.
Sir, as we build our models, the basic difficult part comes in the model deployment or the ML ops. So any tips regarding it?
Sorry?
About the model deployment and ML ops.
So you want to get started in the field of ML ops. I'll suggest one book, Machine Learning Design Patterns from Google Cloud Platform.
Okay.
Start right there. I mean, I could have suggested more, but you know, in the interest of time, I can only provide suggestions that might be helpful for you. Okay. So the book's name is Machine Learning Design Patterns. It's written by folks that work at Google Cloud Platform.
Okay. So thank you, sir.
Cool.
Hello, sir. I'm Anurag. So my question is, like, how do you keep up with your schedule? So you have got a job at Hugging Face. You probably would also be reading lots of research paper and open source. So you might not know me, but I was contributing at Kera CV like 1 month. So my question is about consistency. So how do you keep up with all of these things?
First of all, kudos for your efforts for KRS CV. Really great to see that. Consistency is something that comes with practice. So when I was starting my career, I was more like, okay, read as many papers as possible. Do not focus on the implementation part. And then later I realized, okay, I'm reading a lot. It's time to implement something. Because if you are implementing something that boosts your confidence in the first place. So now it's like, now it has come with habit. You know, I start my day by taking a look at the usual stuff, what I need to do to generate more revenue for Hugging Face, and then I also separate some time for, you know, reading some papers and also contributing to the pending open source PRs that I'm working on. I'll say it comes with experience and practice. So if you are liking something, keep at it, and if you want to transition into the next thing, also try to, you know, take baby steps and try slowly scaling it up from there. Do not immediately jump to, you know, taking a big initiative and then, you know, do not contributing to it. So start taking, you know, slow steps and keep at it. And then, you know, scale them to something bigger.
One more question. So how did you start with like contributing to open source? What was the first point? When and where?
I'm going to be brutally honest. So back in my undergrad days, I was bullied for not knowing open source and GitHub enough. So I made it to a point where, you know, I knew about all the open source related technology. So that started as a booster, moral booster for me. And then it became like a hobby. I really started, you know, developing a niche for the open source community, given the transparency and the kind of opportunities it provides for you. So, yeah.
Thank you. Cool. I might not have introduced myself. I'm Anurag Dharse. So thank you.
Oh, we have interacted, right? Through
no,
Kera
like
CV?
on LinkedIn and Kera CV.
Yeah. Cool.
Thank you.
Thank you.
First,
all right, we need to cut. I'll be around, folks, so feel free to grab me and ask your question. So I'll be around. They are saying my time is...
The last question I want to ask, sir, last.
One question, one more. Who's the lucky guy? Okay, go ahead.
Sir, first of all, hello, sir. Sir, my question is that how cloud computing is beneficial in machine learning?
Oh, yeah. Great question. So can you buy a GPU?
Okay, sir.
Can you buy a high-end GPU, graphics processing unit? Can you buy it?
No, sir.
Being a student, can you buy it?
No, sir. No.
You can't, right?
No, sir.
That's why cloud computing is important, because the cloud platform service providers, they provide you with, you know, managed GPU compute for a cheaper price. And of course, that's more of a jocular answer. Cloud computing is required because most of the cloud service providers provide you with managed services, serverless platforms on which you can practice machine learning to be the great practitioner you always wanted to be. And that set of tools include GPU compute in the first place. And without GPU compute, it's kind of difficult to survive in the ML world, because you want to train your models faster, you want to be on the top of your game, and for that you need GPUs. So one of the reasons why cloud computing is sort of tightly integrated with machine learning is GPUs, cheap GPUs.
Okay, sir. Thank you, sir.
Done? All right. Thank you, folks. Thank you.